Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 57 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice, enormous mug of iced coffee. That would be strong black coffee poured over ice, no sugar, no sweeteners, none needed. I'm also going to need you to get out your Jetson Nano gear, and as you are getting out your gear, as always, I'm going to give a shout out to you guys who are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. You guys that are not helping out yet, think about looking in the description down below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. We are going to learn how to use the GPIO pins on the Jetson Nano as input devices. Last week in lesson number 56, you learned how to use the GPIO pin as an output device. Today, we will be using it as an input device. I will have you make note that on the Jetson Nano, you can only do analog in. So just like as an output, we could write a 1 or a 0. As an input device, we can read a 0 or a 1. Also note that this is a 3.3 volt device. And so 0 volts will be read as a 0 and 3.3 volts will be read as a 1. The other thing that I will tell you is that it appears that the Jetson Nano GPIO pins do not have pull up or pull down resistors, or if they do have them, I was not able to figure out how to activate them. And I sort of looked through the forums and looked at a lot of online resources, and I could not find anyone who had really figured out how to do internal pull up and pull down resistors like we could do on the Arduino. But never fear, I will show you how to do it with an external pull up resistor, and it turns out to be a fairly simple thing. So some of you guys might be a little bit rusty on the old concept of digital reads and the concept of pull-up resistors, and so I will kind of show you that today. And I should say that you can do things with a pull-up resistor, pull-down resistor. The concepts are very similar, but for the sake of illustration, we will do a pull-up resistor. And so let's see if we can come over here and kind of show you what is going on. Let's just say that we are going to use GPIO pin 15. You can choose a number of different pins. Probably I'm thinking just about any of those pins that have a number by them on the GPIO header on the Jetson Nano. Almost any of those could probably be used as an input pin. Don't use something that says 5 volts, 3 volts, or ground, okay, but I think most of the other ones you could use as an input. And so this is on the Jetson Nano. And for the sake of illustration, we will be using pin 15. Then we are going to come over here, and then we are going to hook pin 15 to a switch. Okay, and I will illustrate the switch this way. One leg of the switch will be grounded, and then the other leg will be hooked to pin 15, and then we will illustrate the switch like this. Right now, the switch is off. If you think of this as a button type switch, the button would be up. When you press it down, it will close. When it is up, it is open. Okay, now this is the thing. You can't just come in and open and close it because there's really nothing to read. You have to connect it to a voltage supply, and you want to connect it to the 3.3 volt voltage supply. But you can't connect it directly. You have to put a pull-up resistor so you give that voltage something to drop. Because like, let's just imagine that we connected this directly to 3.3 volts. Well, if the switch is open, this pin 15 is going to see 3.3 volts. But the problem is if you close the switch as configured here, you are going to be seeing ground and you're going to be seeing 3.3 volts at the same time, and that doesn't make any sense. And so that, my friend, will not work. And that, my friend, is why you need a pull-up resistor. Now, I played around with pull-up resistors, and normally I would just throw in like a 10K resistor. For the Jetson Nano, what I found that seemed to work the best was about a 1K resistor. And so what we are going to do is we're going to come into this circuit and we are going to add a pull-up resistor, and that pull-up resistor is going to be 1000 ohms, or you can call that 1K ohm, like that. Okay, and then this does come up, in fact, and hook to 3.3 volts, which you can use pin 1 on the pin 1 on the Jetson Nano. So now let's think about this. Well, if this switch is open, there's no place for the current to go, so there is no current. If the switch is open, there is no current. And what this pin 15 is going to see is it's going to see 3.3 volts because there's no current, there's no voltage drop across the resistor. But now let's imagine that we come in and we close the switch, or for our case, we press the button. When we do that, we have a path for the current to flow to ground, and the voltage is going to drop across the 3.3 the 3.3 volts is going to drop across our pull down resistor, and this pin 15 will then in fact see ground. And so with this pull-up resistor, we should be able to very easily be able to read a 0 or a 1. Okay, so what will you need? For this lesson, you will need a little breadboard, and you notice I am using a freakishly small little breadboard. You will need a push button switch, and you will need a 1K resistor. Now, you guys that went through my Arduino series of tutorials, you have the Elegoo Super Starter Kit, and that will have everything you need in it. If you didn't get this, you can find these components individually, or if you pick up a kit, this is full of generally useful components, and so you get a lot of components for a little money with this. I recommend, if you don't have one of those kits, go ahead and get one. Link down in the description as always. Okay, let's see if we can come over here and change my view so that you can see what's going on a little bit better. We will take a second here to do a little bit of Windows and camera management, and I will get this pointed down where you can see it well. Okay, and then I'm going to call up my focus so I can give you a nice crisp focus. As you guys know, I went crazy with that autofocus never working quite right. And so now we are manually focusing, and even though I have to stop every once in a while to focus, it works a lot better. Okay, so let's go ahead and look at our circuit, and I'm going to kind of be building on the right side of the board here. And let me show you with these little switches what is key. What is key is figuring out, and in fact, I will give you a nice big view of this so that you can see clearly. On most of these switches, what you will see is, I'm going to focus this again. What you'll see on these switches is that they have pins that are sort of pointing towards each other. Do you see how these two pins are kind of pointing in towards each other? And these two pins are pointed in towards each other. So those pins are really one wire. It's like one piece of metal that starts here, goes up, goes over, and comes down. So this is all one. And if I rotate it 180 degrees, this is all one. And the switching occurs between these two. So you've just kind of got to develop the ability of looking at that. The switching occurs right now. There is no connection between this one and this one. When I press the button down, it connects that and that. these two pins that point towards each other are always connected, okay? So we're going to come, and these pins that are pointed towards each other, since they're always connected anyway, those will go into the same column. They need to go into the same column in the breadboard since they are already connected, okay? And then I will press those down securely. Okay, I think I have that switch in there very nicely. And I will give you a better focus here. All right. That looks good. I think you'll be able to see that. And now we are going to bring our Jetson Nano in. Okay. And now what I had said was that we need a pull-up resistor. And so this is my 1000 ohm pull-up resistor, and I will put it on the left leg of the switch, the button. And then I will also put the other leg on the other side of the trench, right? So we know that these columns are connected together, all right, but they're broken over the trench. And so when I make this resistor jump over the trench, now the two legs of the resistor are not connected together. So we said that needed to go to 3.3 volts, okay? And so I'm going to use my female to male wire, and hopefully you have some of those from your kit. So I'm going to come in to that upper leg of the resistor, and then I'm going to come over and I'm going to hook that to this pin that says 3.3 volts. It is pin number 1, and that should not be hard to find. It is the leftmost pin on the outside, and it's labeled 3.3 volts. And so the only thing I don't like about this wonderful Yaboom acrylic case is it does make it a little bit hard to get to those GPIO pins. Okay, I have that on there, and I will show you. Okay, pin 1. All right, now what we need to do is we need to take right where that button was, and let me see if I can, it might be useful for you guys to see the circuit as I'm building. Hopefully you will be able to see this, okay? And so what we've done so far is we have connected to the 3.3 volts. Then we can see the bottom leg of the resistor connects to pin 15, and the bottom leg of the resistor connects to the switch. So the switch is already connected to the bottom leg of the resistor, and so now we need to come in and take that same position, that same leg, and we need to connect to that like this. Okay, and then that needs to go to pin 15 on the Jetson Nano, and that is labeled, it's an outside pin, and it is labeled pin 15. So we have that hooked up now. And then if we look over at the circuit, the final thing we need to do is the lower leg of the switch, the lower leg of the button, which would be right here on the left. Okay, the left connector of that switch, of that button, that is going to go to ground. All right, and if you look, there's a lot of different grounds over here. I see one ground that is just a couple of pins up on the outside from pin 15, and that actually looks like it would be pin 1, 3, 5, 7, like pin 9. It looks like would be a ground. Pin 9 would be a ground. Okay, so let's just review this. I think I will zoom in on this so that you can see it well. Make sure that you have it hooked up right. Starting with the ground, the left of the button, the left leg of the button goes to ground. The right leg of the button goes to a 1,000 ohm resistor, and it also goes to pin 15. And then we have the other leg of the resistor with the red wire goes to pin 1, which is 3.3 volts. Okay, I hope you guys have that hooked up. I think we actually got that hooked up right. And hopefully it wasn't too painful for you. Hopefully it wasn't too painful for you. Okay, so now what we are going to do is we're going to switch back to our, I'm going to switch this around so the button is pointing towards us now. Okay, I hope I don't go too slow on those things. Really, you guys ought to be able to hook up a circuit now from a schematic. We've done this. We've been through enough of these things that you should be able to get where you're pretty comfortable to do that. All right, so that's a pretty good view of that. And let's come back over here to our Jetson Nano. And I also need to get my keyboard because we're going to do a little typing, so we're going to move all this back out of the way a little bit. Okay, get it lined up where you can see it well. All right, I think you can see that pretty well. And then what we are going to do is we are going to call up a fresh new Linux terminal. And now we are going to see what do we need to do to make a reading from that pin. Well, we got to do some things kind of like we did last time in using the device as an output. The first thing we got to do is import rp.gpio, okay, as GPIO. Oh, first thing we got to do is go to the Python shell. I'm sorry, so we type in Python 3, and that will put us into Python. All right, now we're like writing a Python program one line at a time, and it's executing each line at a time. That allows it to be a little bit more interactive. That's why I do that. So now we're going to say import rp.gpio as GPIO. All right, and it liked that, so that's good. The library's there, it's finding it. The world is as it should be. Now we have to do a GPIO.set mode. And remember, this is telling the board what kind of pin configuration we're using. And we just want to use the configuration where the pins are what they are labeled. You know, it's 1, 2, 3, 4, 5, 6, and pin 1 and 2 are labeled. Okay, so GPIO set mode, and we say GPIO dot board. All right, and that will make it use the numbers as the pins are labeled. It's just a lot easier than trying to use any of those other ones. Okay, now we've got to set up our pin. So I'm going to say GPIO dot setup. What do we want to set up? I do believe we went to pin 15, and then what do we want it to be? GPIO dot in. Remember last time we made it an output. This time it's going to be an input. Let's hope it likes it. All right, it likes that. And so we are just going along here absolutely great. And let me do a little Windows management here. I've got to manage this thing a little bit better. You can see I kind of hide notes behind my title bar just so I remember what I am doing without a problem. Okay, so now what we are going to do is we are going to read from that pin. So we're going to say X is equal to what? GPIO. Okay, and then what? Input, and then what? Where are we going to read from? We are going to read from pin 15. And so now this should read the state of the button into the variable X. All right, so it did the read. Now we want to know what X is. Well, what do you think X should be? Okay, what do you think X should be? Let's come back over here and look. Okay, the switch is open. When it's open, there's no current. It should see 3.3 volts. I am saying that I think it's going to read a 1. What do you think? Let's see what X is. Boom. Okay, boom. We read a 1. What do we expect if I press it down? So what I'm going to do is I'm going to call the command up again. I haven't executed it yet, but I'm going to press the button, and now I'm going to execute the command. Now I'm going to come in. What do you expect now? X is 0. Ladies and gentlemen, we are reading digital values from the GPIO pins, and so that is pretty cool. All right, well, let's just go in and let's just write a little code here real quick. This kind of shows that it works. I also need to tell you, always then do GPIO dot clean up, and then we could like clean up pin 15, or we could just do GPIO dot clean up and go like that, and that gets rid of everything. But man, if you leave the program with those GPIO pins locked up, they stay locked up. All right, so you've always got to do that cleanup command. It does not clean up your mess for you. All right, so let's go on over to Visual Studio Code, and let's see if we can write a real quick program here. It's firing up. Okay, and I got a bunch of nonsense up here from the last time that we were playing with this. Okay, so I have a very simple little folder here called GPIO, and so I'm going to add a new program here called simple, or let's call it button read, button read.py. Okay, now we get a fresh new window. I'm going to see if you can watch me coding with this up here as big as it is. I think you should be able to do it. I think you should be able to see. I've just got to make this is a little too big for me to operate like that. And then I am going to bring it over here. Just need to do a little Windows management here so I can make sure you see what I am typing. Okay, that looks good. So what was the first thing that we need to do in this program? We need to say import, and we are going to import rpi.gpio as GPIO. I love this dark background. I know some of you guys hate it, but I just think it's much easier to read. Okay, did I do that right? Not import, import. Okay, I recovered quickly on that one. All right, then I have GPIO dot set mode, and how do we want to set it? We want to set it to GPIO dot BOARD. I think it's uppercase BOARD, BOARD, like that. And now we need to do a, now we need to set it as an output. So we are going to do a GPIO.setup. So GPIO.setup. And then that is going to be, which pin are we working on? 15, and we want that to be in, like that. Okay, I think that should be good. I'm just going to run it, make sure it's happy. Now I'm not going to run it because then it'll lock up those pins, and I haven't done a GPIO clear or a cleanup. Okay, so now let's do a while loop. So I'm going to say while true. When is true true? True is always true. So this is going to loop forever. And then what do I want to do? Well, I want to do a read. So I'm going to say X is equal to GPIO dot input. And then what am I going to input? You know what? Let's be a little bit better because we're going to be kind of starting to program. So I'm just going to say N pin is equal to 15. And then here I'm going to say that is going to be in pin. And then I think what I needed to do here was say this is GPIO.in like that. I think that is the way that it is done. Okay, yeah, I need to put the GPIO in there. And then I am going to come down here and I'm going to read what in pin, like that. And then let's just print X. Okay, now let's right mouse click and run it, and you guys will be looking down in the terminal view down here for what happens. And so we come in and we say run Python file in terminal. Okay, we get a 1 because we're not pressing the button. And we come in and we press the button and we get a 0. Boom! We are reading from this thing, you see? We have button input on our project now. And so that is kind of exciting. Okay, guys, so what have we gone over? This is real simple stuff, but it's taken us 57 lessons to get here because we've done all the artificial intelligence stuff. And so now that we can know what's going around, what is going on around us with our artificial intelligence and our cameras and our sensors and everything, now we can start interacting with the world around us through these GPIO pins. And so we have learned how to send signals to the pins and read signals from the pins. And so this is your homework assignment for next week. Your homework assignment is to get out some of your other components, which we used last time, which was the LED and the most excellent PN 992222. 9222, okay, and then also our resistors, okay, our current limiting resistors. And what I want you to do is set the LED up where it's, when you run the program, it is off, and then when you press the button one time, the light comes on, and then when you press the button again, the light goes off. Now, no fair doing it where the light is on as long as you're holding the button down, because you don't, like if you have a switch, a light switch on the wall, you don't want to have to hold your finger on the switch to keep the light on, right? You want to just press the button, light comes on, press the button, light goes off. And so that is your assignment for next week. Okay, guys, I hope you're having as much fun taking these lessons as I'm having making them. I am having so much fun, and you know, I've got a lot of different series going on right now, but man, this artificial intelligence stuff, this is the stuff that I get the most excited about. If you guys like this lesson, give me a thumbs up. If you haven't already, subscribe to the channel. When you subscribe to the channel, make sure that you ring that bell so that you get notified when my new lessons come out. And think about sharing this on your social media, your Facebook, your Twitter, and so forth. Also, if you want to track me on Twitter, I am Paul J. McWhorter I'm Paul J. McWhorter on Twitter. And if you want to follow me on Facebook, see some of the stuff going on outside of work, I am Paul and then space and Anna, Paul and Anna, and then space McWhorter. All right, and feel free to send me a friend request, and I'd be happy to have you guys kind of track stuff that we have going on outside of work. Okay, again, had a lot of fun. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.